Welcome back into the sim. So we're going to jump into Microsoft 2020 with the CRJ and the Saitek radio panels. There is stuff that works with the standard values. However, we did find some things that currently don't support standard NAV radio frequency for the standby, and we're going to show how to work around that, but also how using SPAD.neXt we're able to leverage a whole bunch of other features like the audio panel. Let's go ahead, jump in. I'm going to show you what we've got. Before we get into it, let's cover the housekeeping. We're running SPAD.neXt 0.9.10.14 in this video. Probably could easily be done with any of the betas or alphas. Get there, you want to make sure that first, and do this before you start the sim, by the way, hop in, go to settings, or here, the gear icon, application settings, expert, change to the alpha channel if you want to be on the same version as me. After you do this, you're going to have to close SPAD.neXt, start it again. It's going to go off. It's going to download the current alpha or beta if you check beta channel. And then once it's done, you need to also install the Elvar bridge. So you got to hop on over to your PC, C, program files, SPAD.neXt, game plugins. If you installed SPAD.neXt somewhere else, I don't know, you go find it. You're looking for SPAD.neXt Microsoft Flight Sim bridge.zip, and you're going to take the contents of this, right? Not the zip, the contents. So drag this folder out and put it into your communities folder in the packages. And the packages is found in users, your username, app data, local packages, the Microsoft Flight Simulator, blah, 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 blah. Again, could be somewhere different. If you didn't do Microsoft Store, if you did Steam, it's wherever it is. Local cache, packages, community. And as you can see, you drag that folder into here. If you want to skip all this and you don't want to learn, you don't care, that is perfectly fine. Head on over to your radio panel. Click anywhere on the radio panel. You're going to go to online snippets. And we're going to go with complete device. And you could either search by author. You're looking for SimConnect Microsoft Flight Sim ASCRJ radio panel. And we go ahead and we click. Now, this should work because it should be the 550s and the 700s. If you don't see it, you can always uncheck only for current aircraft. Of course, lots more will show up, but you'll still find it. We then click on that. Hey, I'm the first to download it. And it will load it in, and now you're done. What is it? Doesn't really work that well. The problem that was run into is on the NAV radios. We can't change it and see it in the radio inside of the sim. What that also means is if you were using the swap command, the swap command's still going to have the CRJ write its private frequency, which there's no Elvar currently for, and it's going to write that into the active. Now, right now, you can see that our active is 114.1. 114.1 is the VOR here at Melbourne. That's currently what's active. So when we write in this special way I'm going to show from the standby that we've dialed up, it is writing and the sim will take it. We've done a little special thing with copying the current active frequency into a fake local variable I created. So in here, we created a local variable and I named it ASCRJ _fake _nav _ standby. So I created my own fake standby and my own fake NAV2 standby. What we're going to do is we're going to set that to the value of NAV active frequency. So it'll copy the current active frequency, stick it into this as a placeholder. It'll do a quick delay of 300 milliseconds, and then we're going to copy the standby frequency that we've dialed up. So what we do see here is going to get copied into the active frequency. So instead of doing a swap, we're going to copy the data and write the data into it, because the swap was triggering the button up here in the sim, not actually putting the data. We'll wait 300 milliseconds, and then what we'll do is we'll copy the standby frequency into the fake NAV standby. Or sorry, the other way around. The fake NAV standby will be copied into the real standby frequency. So we use that placeholder like a little shell game. We took the current active, put it into a little folder. We copied the standby into the active, and then went and got that previous copy and put it back into the standby. So in a way, we created our own swap function. Now, by doing this, what we noticed is this data that shows up in the CRJ is not actually reading the current active of the sim. It'll write to it from its own stuff, but it won't keep in sync. Now, we've seen this before with other things, but we know that it's working. How do we know that it's working? Because if I go ahead and I swap this, what you'll see on here with VOR1 is obviously it's going to be receiving nothing. So if we put 1720 back in, and what you'll see is it wrote the real active, so the panel in the Saitek did update. But you'll see 1720 doesn't do anything. So if we use our cool new feature that we've got and we dial up 14.10 and we do our little copy and paste thing, you'll see it doesn't show up in the radio panel in the RTU, but it does load the correct frequency, and the CRJ is updated, so now we do have the VOR loaded in, and we would be tracking it. So that is really the biggest thing when it came to the data. COM2 was also fully controllable. So using the standard COM2 active and frequency controls, and then also just doing the normal COM2 swap, not a problem. So for NAV1, we used this special function, which is just a copy and swap. Again, we did the same thing with NAV2, only we created a fake NAV2 standby and then did the similar type behaviors. But of course, I did not properly finish that off. So, oops, that's going to copy it to the wrong place. That is supposed to copy it to there. And so copy this into fake 2, not fake 1. And then here, which is copying NAV standby frequency 2, that needs to go into active frequency 2. Whoops, I did half of it. I got the local all done up, but I forgot after the copy and paste to change all these to 2s. So now you saw how I did it. When we look at the ADF works using that same principle, just uses the standard ADF. And what we did, though, was we made the outer knob move a digit, and then we made the inner knob control it. So if I go all the way to the right, it's on the fraction. All the way to the left, it's on the 100ths. So it's real easy to use. It affects it, and you can see the actual ADF does update, so that works as well. The other display is actually displaying the volume, and we're going to get into how that stuff works in a minute. The DME, so the DMEs are reading the DME values, and again, we'll cover how some of this stuff is working momentarily. And then finally, the transponder. So I went ahead and I used the left display to display some other stuff, which we'll cover. But the right display is obviously your transponder code. And what we're going to do is adjust the transponder code. And the outer knob is controlling the Microsoft transponder state. So that's the actual MSF value. So there's 0, 1, 3, and 4. 2 isn't really used. But then what we've got, and if we just come up here real quick, and this is going to show you how we're using these extra values. So what you're going to notice is the upper device, so the active standby button upper. So here the transponder code, this button does this based on the transponder state by 1, right? But it's based on where the active button is. Now, the transponder state is controlled. So we got the display, show transponder state when the upper button is 0. What it means is when I hold that upper button, it's going to use that as the variable. So in holding this down, we're changing what we're showing. So the transponder digit we move by tapping the button, and then we can use the inner knob to change that. But while holding the button, you'll notice the display changes. And now the outer knob, while we hold the button, that's changing the RTU TCAS selection. So this is the one that I have always got caught on, one of the knobs I forgot to switch, which was, why is my ATC not being acknowledged? And it was because, well, I needed to be on, it comes standby, we want to be on active 1. And so 0 is 1, 1 is the standby, and 2 is to use the RTU2 unit. So we're using RTU1, we let go, and we know that the outer knob is the actual Microsoft Flight Sim 1. So some people talked about some of it not working with VATSIM and things. This is just a way to override the Microsoft value, and now it's forced into reporting, I guess. So hopefully that helps with that. So what you saw here was how we could leverage the fact that you can do conditions. When we're turning the inner clockwise, we were incrementing transponder code 1 by 1. But as long as the upper button is 0, so it's not being held, right? So this button here, right on the device, I'm checking the button. I didn't even have to create some type of fake variable. I could just check, is the button being held? And for our displays, we had a similar thing. The right display is always the transponder code. But what we wanted to do was on the left display, when that button's not held, show me the transponder state from Microsoft. Then, if the button is held and is a 1, hello, oh, there we go. If the button is held, so it's a 1, then instead display the transponder active select. So that's the Elvar that we're controlling. So that was kind of cool. Now, I took all of these and I just copied and pasted them down into here, which meant for a lot of what I'm showing you, I had to go through and change everything because all these conditions, of course, we're looking for upper buttons. We changed them to lower buttons. But it's all the same, so we won't cover it. Now, On the DME, now we start getting into, hey, what else can we do with the audio panel related stuff? So here we've got the DME, and we can increment the DME select by 1 by pressing this button. And it's which one are we now controlling? So you can see the inner knob is now controlling the volume right here of DME 2. The outer knob will allow you to turn the audio on and off. So because this has both a volume dial but also a listen on, listen off, I can use this to toggle, get my volume control, and I can use this to do the rest of the functions. So that's kind of cool. That's what we did with the DME, and that's why you've got your what happens, increment volume. We've got the DME volume by 1, so the volume push. So that's your outer, this is your inner. And so with that outer clockwise, DME select session, so that's what we were toggling with that one press. Increment the Elvar DME push, so increment it by 1 every time. And we've got a max of 1, a min of 0, and we don't allow rollover. So I can turn it to the right as much as I want, and it's never going to roll over, so it's always going to be on. And then for the decrement, we did the same thing. Check to make sure that it's 0, and if so, do the same thing. We're going to decrement by 1, but again, minimum 0, max 1, no rollover, so it won't wrap around. Every time I turn to the left, it'll just decrement it from 1 to 0, and if it's already at 0, it's just going to stay at 0. And for the inner knob, we're doing the volume, and all the volumes have a range of 0 to 10. 10's the max volume. So this one was real easy. Increment by 1. Again, same concept. Minimum 0, go to the maximum, no rollover. So I can infinitely turn it to the right, but it will never roll over, it'll never exceed, and it'll never go beyond 10. So I'll never get into some strange value that the sim doesn't actually care about. That's the DME. And again, this here, DME session, again, we created a local variable. We called it DME select, and we can increment it by 1. But in this case, limits are 0 or 1, and it does have a rollover. So every time we tap it, it's going to add 1. So it'll go to 0, go to 1, go to 0, go to 1, because it's just rolling over. When we jump to the ADF, you'll notice, again, a similar type thing. We were using the outer to adjust the control digit of the ADF. Unfortunately, we can't make a visual. That would be neat if we could move an extra dot or blink a dot next to the current one, because there is a decimal point, but whatever. And then we left the right display showing us the volume. If we press the button, it's going to toggle on and off the audio. And for the ADF, I just made it that we're incrementing by 10. Because, all right, either the volume's on or the volume's off. And realistically, listen to it, hear the beep, 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 and get off of it. So this one we did a little bit different. So button pressed for a short time, increment by 1, limits 0, 1, and we put rollover. So it's just going to toggle that push button on and off. And then hold it for longer than a second. It's going to increment by 10, but we're going to give a 0 to 10, but this time we're going to allow the rollover. So it basically can turn the volume on and off all day long. NAV1 and NAV2 are pretty much identical. So again, we'll just cover how the display is showing us if 0, what we're displaying is the NAV active frequency, the NAV standby frequency. If the upper button, so this is that whole thing again where we hold this button and then use the knobs. When we hold the button, it's now going to display for us the on-off state and the volume state. So on the left is the NAV audio on? So you can see in the sim, it's popping open and closed. You can see the value 0, 1. And now while holding that button, turning the right knob allows us to dial the volume and go ahead and turn that up to 10. Then we let go and we are back to the audio. And of course, just like before, 114.10, hey, does that cool little copy swap thing. When we go to COM 1 and COM 2, they are going to be pretty much the same as what we did with the NAVs. We're displaying the frequency. If we hold it down, we're going to display the audio volume level and whether or not we are listening to it as well. So allowing us to control the audios and do that independently. So if we're on COM 2, on COM 2, I can go ahead and I can listen to COM 2, and I can go ahead and I can dial up the volume for COM 2 as well. Now what's really cool is you'll notice we added that on a long press, we're going to activate which one is transmitting, and we'll automatically swap the audio that we're listening to. So we'll do a full transmit swap, and we'll do a COM listen swap. What's also really neat is we added one extra feature for the COMs. One of the things to note, and we'll go ahead and we'll just pitch this up a little bit. One of the things to note is we can have the 833 spacing in Microsoft Flight Sim. So some places use it, some places don't. And when you're not using the 833 spacing, it can be a bit of a pain to be going up in such low increments. So what we did was we added a special little feature. So what you're going to see here is the COM left display. It's going to show you, as long as the upper device is 0 and COM spacing mode is 1, we're actually going to show you the active frequency, but I set the display to make the left digits cut off. And so on the display right now I'm seeing, and of course SPAD.neXt always shows you, even though we know the radio is missing the rightmost digit. Right now I see it as 127.60 and 125.225 on my actual radio. When we enable the COM spacing mode so that COM 1 is using the 833 spacing, instead we're going to display the same frequency, but now we're going to cut off the right digits. And so this way what's going to happen is when we're in that mode, right, now we're going to see the other side. So now we'll see 25.225. To get into this mode, we added a neat little feature. So what we're saying is whenever we press the button, the standby button, less than 1 second, we'll do a normal COM radio swap. But when we hold it for a second, so we do the long press, and we make sure that the lower button is not being held, so it does a check, says this isn't being held, okay, then long button press, I want you to select the audio panel to be 0, so COM 1 is transmitting, and I want you to set VHF1 push to 1, so this is going to go ahead and this is going to open it up and make it what we're listening to, and then set VHF2 to 0. So that's what's making these swap, both the listen and the transmit. So now we got the radio and the audio panel. So this is where it's much better than what you can just do with standard radio panel Saitek. Now, we took it one step further, and we added the feature that if I hold the bottom button, doesn't matter what panel this is on, this can be on the transponder on the bottom for all we care. But what's going to happen, oops, shouldn't have done that with the Lego block operational. All right. What it's going to do is it's going to check, and if this button's being held, then on a long press, it's now going to send the calm spacing mode switch event. So this is an event, not a data value. So it's basically going to toggle the event. We can see we're moving in 0.25 increments. But if I hold that bottom button, so we hold, press and hold, bonk, and now we've switched the mode into 833 spacing. So now it's incrementing by 0.005. And so now we've got the higher frequency spacing for where we need it. And now on the panel, all I see is 27885 because it's always a 1. So here I need to see these 3 digits, and that's more important to me. So this is really, really neat in how we can use the control panel, and with variables and short presses and long presses and holds, we can now combine this functionality and really get a lot of this panel. So I'm not just changing the radios and the NAVs and the DMEs and the frequencies or the transponder or the ADF, but now we're also controlling that audio panel at the same time. This here is the only little tidbit that's a little off. And so again, what we did to work around it was create our own little swap sequence to take it, swap it, get what's actually in standby to the real active that frequency is actually passing through. But like we said, currently their NAV internal to the RTUs is not actually tracking or updating with the SIM variables like the COM1 and COM2 and the ADF and the transponder values are. Thanks for sticking this one out. I know it was, again, another one of these long ones. Hopefully we did it in a better order this time. Hit me up in the SPAD Discord if you have questions about this. Or, of course, leave a comment below. Hit the like button, subscribe, and make suggestions. I was on a previous one of these that somebody asked for the radio panel next. And I thought, oh, okay, well, it's pretty much the same. But then I came up with this idea of how to work around the NAV, and I thought, yeah, this makes sense now. Hope you guys liked it. As always, thanks for watching, and have a great day.